When you specify the database tables, columns, and keys, this is referred to as the logical design. But specifying the table indexes, structure, and partitions is the physical design. Logical design affects query results, while physical design never affects results but can help optimize performance for faster queries. The physical design depends on a storage engine, also called the storage manager, which translates query processor instructions into low-level commands that are able to access data on storage media. The MySQL database has several options for storage engines. There's InnoDB, which is included when you install MySQL, and it's the default storage engine that's used for transaction management, foreign keys, referential integrity, and locking. There's also MyISAM, which is mostly used for analytical applications and provides some limited transaction management and locking capabilities. And there's memory, which provides really fast access to small databases that are just stored in memory. With the InnoDB engine for MySQL, indexes are B+ tree indexes. Primary keys automatically get a primary index, and foreign keys automatically get a secondary index, and you can manually create secondary indexes using create index statements. Tables with a primary key have a sorted structure, while tables without a primary key have a heap structure. If you need a result table to see how a statement such as any select, insert, update, or delete is executed by the storage engine, you can simply run the command explain and then the statement right after it. The physical design process of a database includes first creating the initial design. Here you create a primary index for each primary key and a secondary index for each foreign key. And this is done automatically for you in MySQL with the InnoDB storage engine. And then identify and explain the slow queries. So look at the results of the explain statement for each slow query statement, or check out the query log instead. And then number 3 is to create drop indexes. So after looking at the explain results table, it might be a good idea to create an index when the row's value is high and the filtered value is low. Also, you should drop or delete indexes that are never being used. And then number 4, partition big tables. So if after creating indexes and you're still getting slow queries, maybe you should just try a partition.